All right, welcome back, guys. Today we're going to be doing Chapter 8, Lesson 1.2. What is a typical value? So yesterday we talked about mean or median. Today we're going to talk about how we choose which one's appropriate. So if you guys read along, you are exposed to a huge amount of information every day in school, in the news, in advertising, and in other places. It helps to have tools to be able to understand what the data means. Today you will turn your attention to what you can learn from data. So we're back to this Calaveras County frog jumping contest. So question 12. In lesson 1.1.4, so back in the beginning of the school year, it says you examine results of the Calaveras County frog jumping contest. You saw that the 2009 competition winner jumped 20.5 inches farther than the 2008 winner. Do you think that the winner in 2009 was a special frog, or were frogs in 2009 better jumpers in general than the frogs in 2008? With your team, brainstorm ways that you could compare the two groups of frogs. Recall some of the measures of central tendency from the previous lesson. So what did we talk about? We talked about range, median, and mean. So here we have our data, and if we look at 2008, let's count together how many sets of data we have. 1, 2, 3, 4, 5, 6, 7, 8. And in 2009, we have 1, 2, 3, 4, 5, 6, 7, 8. And we want to, so could we find the range? Could we find the mean? And could we find the median? Sure. So in question A, all right, so question A says our first job is to go ahead and create a graphical representation of the data. So many statisticians say that the first and most important step in analyzing data is to make a graphical representation. So we know bar graphs, we know line graphs, we talked about dot plots, we've talked about histograms. Histograms are a special type of bar graph. So in this lesson here, we want to talk about how to create a lesson of the data, or look at the ones that your teacher displays for you. And we want our histograms to be of bin sizes that are 10 inches. So we're going to go ahead and create a histogram. Ms. Lanzo has here already drawn on the board for you guys a histogram. So if you guys can go ahead and take a minute and jot that histogram down. Notice that the directions tell us to have bin sizes that are 10 inches long, or 10 inches in difference. Remember a bin, we talked about in the beginning of the school year, a bin is something we use to organize things in. Even at home we use bins to organize different, holiday decorations or our toys or our crafting stuff. And we put like things in that bin, or in those totes. So here we're putting in like information in each of these, we call them bins. So this bin here is going to contain information from 210 up to 220, but not including 220. As soon as you get to 220, you go into the next bin. Okay? So this has information from 220 up to 230, but as soon as you hit that 230, it goes into the next bin. So think about your tote. As soon as your tote is full, you have to get a new one. So we're going to go ahead and you guys kind of plot the data along with us here. So Skeeter Eater is 231.5 inches. We're going to go ahead and use our dots to go ahead and put them in the correct bin. 230, 229, 227, 221.5, 220.5, 217, and 216 5/10. So our histograms, we use the dots, but our histogram is a special type of bar graph. So we're going to go ahead and show this to you guys as a bar graph. And lots of different things that we talked about in the beginning of the school year, which bin has the most number of sets of data and that kind of stuff. So we can make some different trends based upon our histogram here. Okay? But remember, the other special thing about a histogram is that your bars actually touch, because there's no transition from one into the next bar, one bin into the next bin. So why was a histogram a good choice? It allows us to see the connections between the patterns in the data, such as the spread and the shape. So we can see that this has a nice arcing shape, so it starts low, high, and then low again. We can also see, we can use that information to figure out how the data is spread out. Okay, if it's all clustered together, or if there are outliers, or if there's a cluster of data here in the middle. So use the information that we kind of stepped you guys through with 2008. You guys are creating a histogram now for 2009. So again, we have it set up for you guys here on the board. You guys have the bin sizes of 10 inches, 180 to 190, 190 to 200, etc. So they are, again, our intervals of 10. So go ahead and take a few minutes and take your data from the 2009 Calaveras County Frog Jumping Contest and make your own histogram. All right, so by now you guys should have been able to create your own histogram. So if you guys look at the histogram here that Ms. Lanza created for you guys, what are some different things you guys notice about your histogram?
So I noticed that there is a gap that we have no data from 190 to 219. We also see a clump in the center, which ranges from 220 to 240. And then we have this little one out here, 250 to 260.
So we're trying to figure out what are some differences between our sets of data. Why are these two histograms used to show these 2 years of data? So something you may notice in 2008 is that this data is more symmetrical. Okay, it's more symmetrical, whereas this data in 2009 is more kind of spread out. It's staggered. Like Ms. Lanza said, there's some gaps of information here. A lot of our information here is centered here. We might be able to say that in 2009 there are some outliers here because that's the set of data is not, it's kind of separated. It's kind of like the outcast of that set of data. Whereas in 2008 it doesn't seem like there are any outliers because all of our data is clumped together. So question B just talked about what are some obvious things you guys notice about your histograms. And Ms. Lanza and I discussed with you guys some things that we saw. So maybe you guys can come up with a couple other things. One good thing to always have in your histograms, like Ms. Lanza has here, is the number of sets of data that are in each in each bin. So question C says the technology tool shows the mean and the median of the data below the histogram. However, if the mean and the median were not labeled, would there be a way to determine the median or the mean from a histogram alone? So go ahead and pause the video and think about, could we go back to our two histograms and find the mean or the median? So what did you guys come up with? What did you come up with, Ms. Lanzo?
I came up with that we cannot determine the mean or the median of this set of data because...
Well, why not? It's right there. Why can't we find out the mean or the median? I feel like you should be able to find it.
Well, it's the data here shown is not giving us the precise number of what is inside the bin. So we don't know between 230 and 240 what these two numbers are, number data sets.
Yeah, so you're saying that one of those data, it could be like 230 and one could be 235 or maybe it's 237. So we don't know the actual number of that data that's in there. But if we did a traditional bar graph where we labeled every single one of those points, we wouldn't be able to find the trends that we could with a histogram when we lump stuff into like size bins. Great explanation, Ms. Lanza, and I'm sure our students out there came up with equally, if not better, explanations than we can come up with. So moving on to question 13. Use the list of data in problem 8-12 or the histograms that you or your teacher made, so we made them with you guys, to continue to analyze and compare the frog jumps for both 2008 and 2009. Question A, what was the range of the jumps each year? So we just talked about we couldn't really use our histogram to find out the range because we don't know the exact numbers. But we do have the exact numbers in our table. So if you look at the data from 2008 and the data from 2009, could you guys go ahead and find the range? So go ahead and pause this video and find the range for both 2008 and 2009.
Don't forget, you need to order them from least to greatest. Or greatest to least.
So I can see from our histogram that we have 1, 2, 3, 4, 5, 6, 7, 8 sets of data. And I like to put the number of lines, so 1, 2, 3, 4, 5, 6, 7, 8 lines with the numbers so that I know I have accounted for all my information. So we went ahead and ordered it least to greatest. This is obviously our smallest number, and this is our largest number. So if we're finding the range, it's the largest value of our data minus the smallest of our data. And that would give us a range of 15 for 2008. And what about 2009, Ms. Lanzo?
So I went ahead and did the same thing. I ordered my numbers from least to greatest, and we took our greatest number, which was 252, and we subtracted it from 185 and 25 hundredths, and we got 66 and 75 hundredths inches. I forgot my label.
Oh, I also forgot my label. Thank you. So what does that range tell us? It tells us the range of information here in 2008 is 15, and 66 and 75 hundredths is a lot larger than that. And if you look at our histograms, we said, hey, our data here was pretty closely clustered together, and over here, pretty far spread out. So when we have a smaller range, we can talk about our data is more consistent. It's not as far spread out. The data is more closely connected. There's probably not very many outliers, if any. Whereas if you guys have a larger range, that means there are more discrepancies in your data. Maybe this person collected their data incorrectly. Okay, it'd be like, if you're running a race and everybody has times of around 6 to 7 minutes, and then you had somebody who walked and got 35 minutes. That person who ran or walked in 35 minutes would throw everybody else's times off. So that's called an outlier, and that's going to affect our range. Okay. In question B,
what was the typical jump length of the frogs each year, and how did you find this value?
So we just found the range. They're asking, what are they asking us to find if they want us to know the typical number of lengths of each frog each year? So we found the range, so it probably leaves us with the median or the mean. So could we find them both? So go ahead and pause the video and find the mean and the median for your data for 2008 and 2009. Get back on task, Ms. Lanzo. All right, in 2008, so we had our histogram where we organized our data. We organized our data least to greatest, and we were able to find the range. The mean, remember the mean is the average. So how do we find the average or the mean? We add up all of our values, and we should have got 1,793. Why are we dividing it by 8? Because we have 1, 2, 3, 4, 5, 6, 7, 8 sets of data, which also corresponds to our 8 sets of data up here in our histogram. And when we divide that, we get 224 and 125 thousandths as our answer. The median, remember the median is like the middle number. So let's go ahead and use Ms. Lanzo's strategy. So we cross off the first and the last and the second to last. And eventually we find that in the middle we have 2 values. So some of the earlier problems we had, it was pretty easy to decide what was in the middle of those 2. So if we have these 2 and we want to find the middle of it, we can add them up and divide that by 2. Add them up, divide by 2, and we get a median of 224 and 25 hundredths. Because we divided by 2 because we want to know what is the middle of these 2 values. So what we're taking their sum and dividing into 2 equal groups. In 2009.
So for 2009, I did the same thing as Mr. Baldwin to find the mean. I went ahead and added all of our set of data up, and I got 1,875 hundredths. And then I divided it by 8 because there are 8 pieces of data, and I ended up with 225 and 9 hundredths. So that would be our mean. And then for our median, again, I used a different strategy. Instead of crossing out my numbers in case we needed them for future reference, I just went ahead and put a dot under each of my data points. And again, I also got two numbers in the middle. Then you go ahead and you have to add the two numbers up, and I got 450, and you have to divide by 2 because you have the two numbers in the middle, and you need to find what's in the middle of those. So when you divided it by 2, I ended up with 225 as our median.
Okay. So letter B, when it talks about wanting us to find typical jump lengths, we were able to find both the mean and the median. Okay, and we're going to talk later about which one of those we might want to use more consistently. So in question C, were the jumps all about the same, or were there some outliers? Remember, an outlier is kind of like the outcast of your data. It doesn't belong. So, I don't know, Ms. Lanza, do you have outliers in your set of data?
I think I do.
How many outliers do you have?
I would say I have this as an outlier and this as an outlier because most of my data, which are 6 points, are centered as these two data points are out towards the edges.
So if you look at your histogram, we know that they fall somewhere in the 180 to 190 range and the 250 to 260 range. Can we use any other data to tell exactly what those outliers are equal to?
We can go to back to our table and look at what our outliers are. And according to our table here, my first outlier over here is 185 and 25 and my outlier on the other side is 252.
So Dr. Frog jumped really not very far, so maybe he was feeling sick that day.
He was sick.
And for the sign, I think he cheated. He
didn't cheat. He had a nice hop.
Nice hop. Yeah, I think he cheated. Maybe he's on steroids or something. In 2008, if you look at our data. Okay, so going back to our histogram, going back to our range, the range is pretty close or not very far apart.
Do you feel like you had outliers?
I don't feel like I have any outliers. Do you agree?
Me? I agree, yes. Do you guys agree out there?
All right. Last part of question 13. Compare as completely as you can the 2008 jumps to the 2009 jumps. Compare the center, the shape, the spread, and the outliers. Then draw a conclusion. Were one year's frogs a better group of jumpers than the other? How do you know? So go back and go ahead and see if you guys can put all of this information for 2008 and 2009 maybe in a table or in some kind of graphical representation to see how you guys would compare the center, the shape, the spread, and the outliers for 2008 and 2009. So we're going to go ahead and work on it on our own. You guys pause the video and go ahead and do it on your own. Alright, so some of the things that you guys should have noticed was that in 2009, we had a group of frogs that jumped much farther than in 2008. Okay, and you guys can see that just by comparing the different measurements, the different data points for those frogs. However, we noticed in 2008 that the frogs jumped more consistently, meaning there were no outliers, they were all around approximately the same distance, whereas in 2009, they were a little bit more spread out. Okay, moving on to question 14. It is important to look at the distribution of the data when deciding whether to use the mean or the median. Remember, the mean is the average, the median is the middle value. In 2008, which represents a typical jump better, the mean or the median? So if we go back and look at the data from 2008, we will see that it really doesn't matter for that data because our mean and our median were both pretty close to one another. So in this sense of our data being more consistent, it doesn't really matter which set of data or which data point we use, or if we try to find the mean or the median. If we go back to question B, it says, what if the 9th place jump in 2008 was very small, such as 160 inches? Redraw your histogram from problem 8-12 and include this new jump. So if we take one of our magnets here and we say that that jump was 160, that's going to be, somewhere all the way back here, okay? And that's clearly going to then be an outlier in 2008 now, because it didn't go along with the rest of our data here. So if we're going to go ahead and do that, and we added this 160, to our data for the mean and the median, meaning we're going to add 160 here, and we're not going to divide that by 9, okay? We're going to find out that our mean is going to become 217, okay? Because when we add that, we get 1,953. And when we found our median, if we go ahead and add 160 again, it's going to be cutting down here in our low end. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sets of data. So if we find the middle, cross up the first and last, second last, and so forth. We're going to find out that our middle value is now 221 and 5/10. So depending upon the outlier, how high or how low it is, it can have a drastic difference on our mean and median. Usually, though, there's a bigger difference with the mean, because the median is just going to fall left or right to the next closest value. But if you think about the mean, like a test, if you had an A in class and then you got a 50% on a test, that's going to dramatically decrease your grade. Or vice versa, if you had a bad grade and you got 100%, that would drastically increase your grade. So letter C just had you guys going ahead and making your prediction and how did that affect your mean and your median. Okay, I guess I should have had you guys pause and go ahead and do that. And letter D says use your calculator to test your prediction, which we just did. We found out what the mean and what the median would be. Letter E says look at your histogram from part B. Does the mean or does the median better represent a typical jump in 2008? So in 2009, we said that there wasn't, in 2008 we said there wasn't a big difference originally. However, when we go ahead and add in that additional number, the median is going to be a better indication or a better representation of an average jump or a typical jump. Because it's not, this outlier of 160 isn't dragging this down a whole lot. So letter F, when does the median represent a typical jump better than the mean does? So the median is typically a better indication of something that's average or typical when there are outliers present or when the data is not symmetrical. So if we look at our data from 2009, we have data again that is not symmetrical, and there are outliers. So if we wanted to know typical information for 2009, we would also use the median instead of the mean.